Hello, good morning, my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry from Infinity Land NEET YouTube channel. How are you all preparing for your NEET examination? आज हम चर्चा करने वाले हैं thermodynamics boards से NEET तक 2025-26 series. How are you all doing, my dear students? Just can you able to hear me? Can see me? Give me a thumbs up and fire emoji. So ये thermodynamics ऐसे टॉपिक है ये फिजिक्स का बराबर देखता हूँ. Majority of the students, I can say as a faculty, you study biology well, chemistry okay, but when you talk about the physics, you will be having kind of glitch or you can kind of fear because it is a physics and it has a mathematical approach, isn't it? So this is the topic, it appears like that, and no worries, today I am going to help you out of this, how to take marks out of thermodynamics. Agree? Hello? Charita Sri, I can see you guys. Right, a thumbs up and fire emojis so that we can start thermodynamics. So thermodynamics is a very important topic. It is connected to the total physical chemistry and also certain points in the inorganic as well as an organic chemistry. And this thermodynamics gives a lot of emphasis. It has a double tone. Physical thermodynamics and chemical thermodynamics. आज हम चर्चा करने वाले हैं physical thermodynamics and zeroth law, first law, second law and third law. And all aspects as far as the thermodynamics is concerned and all derivations. अरे derivations इतना important है, अरे इतना काफी important है ताकि ये derive करने के बाद output लेना चाहता हूँ. You don't have to derive it. I will derive it and I'll show you it and how to use the formula and what are the conditions. And we strictly connected to NCERT and we strictly adhere to NEET syllabus given by NTA. So, bachcho, don't leave the session and please take a pen and paper, write all noteworthy points, and without delay, I am going to start the session. And this session is going to be a 3-hour session and we'll take a couple of breaks in this 3-hour session, and without pressure we can complete this session, right beta? आज तबीयत इतना अच्छा नहीं है, लेकिन for you I don't want to disappoint you. I can take you to the session to the highest extent. So what is thermodynamics? So आज का हमारा session है. It is useful for those who are preparing. Those who are in 11th standard, 12th standard, NEET repeaters को भी है. And you see, thermo means heat and dynamics means moving, and the various forms of energy is interconverted and can be transformed from one form to another form. So we are going to talk about the heat. In thermodynamics, whenever I say energy or heat, these two are synonymous. But so in that, what we are going to learn in thermodynamics. So it's a branch of science which deals with different forms of energy and their interconversions. Heat energy is converted into electrical energy is converted to thermal energy, like that. Deals with matter in bulk. It is only applicable for the macroscopic properties and not at the level of atoms, not at the level of electrons. You can't apply thermodynamics. You can apply thermodynamics laws only at the level of bulk or the matter, and properties associated with the bulk are called macroscopic properties. So बच्चों मैं क्या कहना चाहता हूँ आपको, so thermodynamics ऐसे टॉपिक है. Why it is connected to the chemistry? In one phrase I just want to tell you. Chemistry is all about study of chemical reactions. What happens in the chemical reactions? ऐसे chemical reaction मान के चलो, reactant is converted into product. Yes, everybody knows that. Study of chemical reactions is called chemistry. Now, उसमें a chemical reaction, any chemical reaction, whether it takes place or not, whether the reaction आगे बढ़ेगा नहीं है, that is decided by thermodynamics. once the reaction takes place, how fast the reaction takes place, that is given by chemical kinetics. And once the reaction is given to the product, how much product can be given back to the reactant is given by equilibrium. So you say equilibrium, thermodynamics, chemical kinetics, these are the three areas, core point of your physical chemistry. अब क्या मानता हूं? And wherever numericals are there, you say physical chemistry. Isn't it? No, it is absolutely not. They may come under electrochemistry is a part of thermodynamics and equilibrium derivatives. है ना? अरे चरिता श्री, how are you? Betu is there online today? बच्चों, Anuj Gope is there? बच्चों आगे बढ़ता हूं. And here I just wanted to understand what drives a chemical reaction and energy changes involved in a chemical reaction, the extent of completion of the reaction, and the criteria of the prediction of the feasibility, and everything we have to understand when you talk about the thermodynamics. So why do we need to study thermodynamics? So these are the questions can be answered by thermodynamics aspect. So from the thermodynamics, if you are preparing for NEET examination, definitely 2 questions will be there. 2 questions means you are going to have 8 marks. Directly 1 question and indirectly is connected to another question. So जो delta G आता है ना at the end of this thermodynamics, that is connected to equilibrium, that is connected to electrochemistry. Yes, Gibbs free energy is the deciding factor. So बच्चों, let us see what we are going to say in the thermodynamics. You need to talk about the system and surroundings and the boundary and all the basic terminologies you need to know about this thermodynamics. Bachcho, use this chat box and please ask any kind of doubts that is going to happen right now. And let us see what is a system. A system is a part of universe. Don't go, universe means you don't go in the cosmic zone. So universe means everything around us, okay, and is a part of system which is under thermodynamic study is called as a system. You have various systems, include everything else in the universe other than the system is called surroundings. You take a cup of coffee, so that is going to be a system. Around the cup of coffee is going to be surroundings. A boundary, a real or imaginary interface which separate the system and surroundings is called as a boundary. And you take a kettle of coffee and this is going to be a system and this is going to be imaginary boundary on the surface you can see, and it is going to be real boundary. You have various types of boundaries, various types of systems. अरे इंट्रोडक्शन अच्छा चलता है, यही पेस, यही कंटेंट, इतना ब्यूटीफुल प्रेजेंटेशंस विल बी थ्रू आउट द सेशन. स्टे ट्यून्ड बच्चों. एंड हियर यू कैन सी a boundary. The boundary can be a rigid boundary. This is a system gas cylinder, and this boundary cannot change the volume of the system. That is called rigid boundary, rigid wall boundary. And this is what is called as a flexible boundary. When this gas is cylinder and the piston is going to be moved here and there, the boundary is going to change the volume of the system, is called as a flexible boundary. समझ में आ रही क्या बेटा? And also it can be conducting boundary, it cannot be conducting boundary. Sometimes you see this is the boundary where it can exchange the heat from the system and surroundings. So it is called diathermic, it can conduct the heat. While thermoflask you can say, so it is called adiabatic boundary or adiabatic wall, and it cannot exchange the heat. Diathermic and adiabatic. And thermodynamics, the basic terminologies are very important. We are going to find these terminologies can give you the maximum extent of the subject. So bachcho, let us see other aspects of this boundary and system. You can say universe कहते हैं आपको, system and surroundings is going to be universe. So system is a part of the universe where thermodynamics is investigated. And apart from this, anything about the universe except the system is called the surroundings, and it is what is called universe. You have various types of systems. Better, you can see open system, closed system, and isolated system. You take the example, it's self-explanatory. Open system is a system which can exchange the heat as well as mass, and closed system can exchange only heat, cannot mass, and isolated system neither exchanges heat nor mass. So this is all about the types of systems, and we are going to see the other terminologies. State of a system. So what is the state of a system? I say, what is the physical state of this? What is the physical state of this? It can be a liquid when temperature is going to be 25 degrees centigrade. It can be a solid when temperature is going to be 0 degrees centigrade. It can be vapor, and when temperature is going to be 100 degrees centigrade. मैं क्या बोलना चाहता हूँ? Temperature is the parameter which decide इसका state क्या होगा. चाहे इसको solid हो सकता, liquid हो सकता, gas भी हो सकता. And this is what is called as a state of a system decided by its temperature. So, state is defined by measuring the observable properties of a system. These are called state functions, PVTN. Pressure, volume, temperature, and number of moles. So, a condition in which the state is present is called a state. Chahe iska state means it could be a liquid state or a solid state. Even in the liquid state, water 25 degrees centigrade is a state. Liquid water at 99 degrees centigrade is another state. 50 degrees centigrade is another state. Liquid mein itna states bhi hota. Charitasri is very important. Okay. Now, state functions. So, the values depends upon only the state of a system during a process. It depends on only the initial state and the final state, but not dependent on the path of the system. And this is dependent on the path by which the change has occurred. Is called as a state function. Pressure, volume, temperature, and blah blah blah. All these processes, all these are called state functions. Let us talk about the path functions. Path functions are the functions which depend on how the change occurs. So, depend on the path by which the system is achieved the particular state. Okay. So, in this live session, you please see the description box. Many things are there. You can just find out. And those who are online, I request you guys, please like the session and share with your friends and subscribe to this channel. So, this channel is going to be helpful for the entire society who is preparing for NEET examinations, my dear children. And let us talk about they can't have any definite particular values in any particular state of a system, and you will be having only two state functions, that is heat, that is given as a Q, work, that is given as a W. So, these are called path functions. So, I mean to say here, you see a beautiful image I want to show you here, bacho, and I want to go to these state 1, first floor से second floor जाना है, it's path 1. So, ये condition में, this condition only elevator A floor में रुकेगा, elevator A floor में रुकेगा, बीच में कभी नहीं रुकेगा. Okay, there is no state. And you can see this is another path, and you can have various stages in this. So, it all depends on, this is a path 1 and this is a path 2. Okay, it can have one step, it can have multi-step. So, it is an irreversible bhi kar sakta hai, and it can be reversible. Hey, that's very, very important. It could be reversible. The moment he is going up to here, he can come back at any time. But he want to go from this state 1 to state 2, he has to go to state 2. Otherwise, he can come back after state 2 to state 1. But beach mein change the mindset and you want to come back, it is not possible. Not possible at all. Right, beta? That is very important. So this is an example for the irreversible and this is an example for the reversible. समझ में आ रहा है क्या बेटा शीतल, Taitrashri? And moving ahead, quick state function and path function, quick contrast examples you can see here. It is independent on the path that is taking place and depends upon only on the state of a system, bacho. And multiple path results in the same value because it is independent of the path. And example, any value, any measurable properties. Any measurable properties. And talking about the path function, it depends on the direction in which the change has taken place. That is called depend on the path taking place. And depends on how the state of a system has been achieved. And also multiple path may result in the different values. So example, only two path functions are there, heat and work. So you can see the capital letters for mention the state function and the small letters for mention the path functions. अगर कुछ डाउट है ना तो आप पूछना सीधा, मैं तैयार हूँ आपको डाउट बोलने के लिए जल्दी, waiting for you. Okay. Okay, now moving ahead, so macroscopic properties and their intensive properties, macroscopic properties, extensive properties. See the depth of the terminologies that we are going to see. So intensive properties, these properties depends on the mass, size of the system. You can take volume. Volume is a parameter, depends on the container and the volume, the mass of the system. And extensive properties depends on the mass of the depends on the mass of size of the system. It is independent, intensive, and extensive, it is dependent. You can say density, it is example density I want to say. Here example I want to say volume and moles and the mass, and these are all the various examples. I will tell you the important factor. Do we have to memorize these intensive properties list and extensive properties list? No, I will talk about intensive property. Water, pure water, density is 1. You take a glass of pure water, density is 1. Jug of pure water, density is 1. Tank of pure water, density is 1. So how much amount of water you have taken, it is independent. Density is independent on the amount of the substance present in it. So it is an intensive property. Are you getting or not? So you have to inculcate like self-learning, self-teaching is important, bacho, right? So I want to say a cheese NEET में सीधा इस्तेमाल करो बेटा. NEET में ratio of two extensive properties is an intensive property. You can say density is equal to mass by volume. Mass is an extensive property and volume is an extensive property. ये रेशियो दोनों का बीच में जो डेंसिटी मिला हुआ है इंटेंसिव प्रॉपर्टी बनाए. And you have various extensive properties, intensive properties, volume, number of moles, mass, free energy, and entropy, enthalpy, internal energy, and heat capacity. These are all extensive properties. And molar volume, density, refractive index, surface tension, viscosity, free energy, specific heat, pressure, temperature, boiling point, freezing point, etc. are going to be intensive property. Whenever extensive property is expressed per mole is going to be intensive property. This is also very important. And also thermodynamic equilibrium. Arre baapre. Very important. So what is the meaning of an equilibrium? There is no change in any observable, measurable property of a system at a given time is called as an equilibrium. This equilibrium, thermodynamic equilibrium, तीन तरीका होगा, and it is going to be mechanical equilibrium, thermal equilibrium, and chemical equilibrium. Bacho, you can see what is a mechanical equilibrium. These two kids are playing on pushing equally, and you can say no pressure gradient within the time is a mechanical equilibrium. So the diagram itself is self-explanatory. समझ में आ रहा है क्या बेटा बच्चों? Chaitrasri 2581. And you can also see thermal equilibrium. So thermal equilibrium, no temperature gradient with respect to time. And the chemical equilibrium, no concentration gradient at any species in the system. So thermodynamic state parameters are only defined when the system is in thermodynamic equilibrium. That's very, very, very important. So you have a state function. State function kab karna hai? Theoretical questions. I am going to tell you, NEET examination, you will be having maximum 5 numericals in the total, 5 to 6 numericals maximum. But physical chemistry से questions कैसे निकलेगा? Theoretical questions, which of the following is true, which of the following is incorrect, kind of. So assertion, reasoning type of questions, and everything is important as far as this physical chemistry is concerned. And you may be asking a couple of questions in the based on numericals, and these numericals you can do by using tricks, and we are going to discuss some numericals based on that also. Stay tuned. Bachcho, moving ahead. So thermodynamic process. So thermodynamics process होता है क्या? ये जैसे process में a system changes from a state to another state, and that operation is called as a thermodynamic process. है ना? And we are going to see various thermodynamic processes. And let me tell you the list of thermodynamic processes. So use the short box to ask any kind of questions. So isothermal process, adiabatic process, isobaric process, and isochoric process, the cyclic process. And these processes can be explained point to point. Okay. And you see here, so isothermal process, the process, so thermodynamic process in which the temperature remain constant. So what is the meaning of that? Everybody can say dt is equal to 0. So when dt is equal to 0, I want to say it can exchange, a system is going to do some work in such a way that it can exchange heat with surroundings. It can exchange heat with surroundings. That is what is called isothermal process. And students here, adiabatic and isothermal are confusing for the students. But I just want to show you what is an isothermal process, and here it is an adiabatic process. Adiabatic process is a process in which the heat exchange is 0, dq is equal to 0. In the previous process, dt is equal to 0, and in this process, dq is equal to 0. And the system is not exchanging heat with the surroundings, is called as an adiabatic process. Chaitrasri. Betu is there in the class? Hello, Betu. And looking into this, heat exchange is not there. Now, isobaric process, dP is equal to 0. The system in which the pressure is maintained constant, so that it can have movable piston, then only it can maintain pressure constant. And also dV is equal to 0, that is called a isochoric process. So the process in which the volume is constant, so that the piston is locked so that it will have a rigid container. So bomb calorimeter, jab bomb calorimeter hota hai na, you can assume this is called isochoric process, right? And understanding here, isobaric process, pressure is constant, dP is equal to 0, thermodynamic work, we know that W is equal to P delta V, so W is equal to F into dl. So PA dl, pressure into area and change in the length when the piston is raising. Now let us apply this. So P delta V. So isobaric process. If the question poses, I am telling you, आज सेशन में आपका ट्रिक्स भी देना चाहता हूं. अगर ये थर्मोडायनेमिक्स क्वेश्चन आपको पूछा जाएगा तो कैसे? Is not given, there will be a consider isobaric, because the maximum processes are carried out in open vessel where the pressure is constant. This is, if not mentioned, we have to use this criteria. Okay, so let us move ahead and use a graphical explanation is also very important. Beta, you can see here isochoric process. In the isochoric process, volume is constant volume container, so delta V is equal to constant, thermodynamic work is constant. Kaise? You can see here P delta V, W is equal to P delta V. अगर delta V 0 होगा तो W भी 0 होना चाहिए. So this is what is called as a isobaric process. This is what is called isobaric process. अगर कुछ doubt है ना तो जल्दी पूछना. So process, I am taking this class in such a way that you are in the laboratory and you are witnessing something is happening, pressure is increased, you can see there is a process that is taking place. ताकि इसका वॉल्यूम जब तक कांस्टेंट होगा उसका वर्क डन भी 0 हो सकता. Are you getting or not? Chaitra Sri, come on, those students who are online, please like the session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. Okay बच्चों, आगे बढ़ता. And you can see isothermal process. You can see it is going to be, yeah, temperature is here and it is going to be temperature is dt is equal to 0. Why? During this process, this system is exchanging heat with the surroundings. जैसे process होता है isothermal process. You know isothermal process में क्या क्या चलते हैं? Delta U, internal energy is going to be 0 क्योंकि internal energy is directly proportional to temperature. Energy is directly proportional to temperature. जब तक temperature constant है, internal energy constant है. Are you getting or not? So this is not a rocket science. बच्चों, my dear future doctors, you can do well because you need to be so meticulous in calculations when you are treating a patient. Okay, so these kind of things or the basic terminologies you need to have in your mind so that you can do the best of the thermodynamics, my dear children. And let us see here isothermal process, dt is equal to 0 for an ideal gas. PV is equal to constant, so P1 V1 is equal to P2 V2. So for an ideal gas in isothermal process, I said delta U is equal to 0. Internal energy change is always 0. And internal energy is equal to kinetic energy by 3 by 2 RT. So internal energy is directly proportional to temperature is equal to change in internal energy. Okay, as जब तक temperature constant है, internal energy भी constant होगा. So I want to say here, so in this isothermal process, I want to show you ideal gas isothermal moles. So delta H is equal to delta U plus delta nRT. Delta H is equal to enthalpy change. Delta U is equal to internal energy change. And delta nRT, R is a gas constant, T is a temperature. Delta N is equal to number of moles of gaseous products minus number of moles of gaseous reactants in a process, right? So if you take this log P versus log V, we know that P is inversely proportional to volume. So if you take a graph between P and V, So P and V, you are going to get rectangular hyperbola as long as temperature is constant. It is given by Boyle's law. When P versus log V, log P versus log V, it is an isotherm because PV is equal to constant, log P plus log V is equal to log K, log P is equal to minus log V plus log K. So it follows Y is equal to mx plus C. So do you say this is sir chemistry sir अचानक आके physics पढ़ा रहा है? And yes, sometimes physics and the chemistry are brothers and sisters. So what is V belongs to? V belongs to, okay, Yogita, it is volume of a gas and P is the pressure of a gas. It is going to be log K versus log V is going to be a straight line, and intercept is going to get log P and the slope is equal to -1. That is going to be very important, very, very, very important. Okay. अगर कुछ डाउट है ना तो जल्दी पूछना बच्चों. Now moving ahead बच्चों, meaning of isothermal. Iso means same, thermal means heat. So the process which goes at the same temperature is called isothermal. Okay, so keep asking any kind of doubts. I am going to hear me. Yes, and gamma is the Poisson ratio. This is Cp by Cv. We are going to address what is the ratio between Cp and Cv, and we are going to see the details about this an adiabatic process separately, and we are going to see the difference between this is an isobaric process, P versus V, and you are going P versus V graph, and in isobaric process, isochoric process, isothermal process, adiabatic process को थोड़ा सा ग्राफ नीचे से आना पड़ता. And also moving ahead, a cyclic process, a process which will proceed in such a way that it undergo n number of changes and return to its initial state is called as cyclic process. Okay, in the cyclic process, it is going to be at a PV versus V graph is going to be a cyclic. It changes from here to here, here to here, here to here. It is going to be a cyclic process. In the cyclic process, enthalpy change is going to be 0 and internal energy change is also going to be 0. So, बच्चों, yeah. So, Hitesh Kumar, Now let us talk about PV graphs. This is very important graph as far as the NEET examination is concerned. Okay, so you are going to see pressure versus volume, and volume is constant. This process is called isochoric process, and pressure is constant, isobaric process, and isothermal process, rectangular hyperbola, Boyle's law का हिसाब से, and adiabatic process, the curve is going to be like isothermal process, but it is going to be little down as compared to the adiabatic process is down as compared to isothermal process. And what is a cyclic process? We already discussed. A cyclic process ऐसे process है, a system undergoes n number of changes and come back to its original state is called as a cyclic process. ठीक है? And delta H is going to be 0, delta U is going to be 0. Okay? And also, so thermodynamic process उसमें आपका आना चाहिए based on the way the process takes place, and a reversible process and irreversible process. What makes the difference between reversible and irreversible? A process which takes place in a single step is called a irreversible process, and infinitesimally small steps to finally, and it changes from another state is called as irreversible. Look at this. Yeah, in the reversible, so multi-stepped, you just see reversible process in an ideal process, it is hypothetical process, and it takes infinite time to complete it. And you know, the driving force is infinitesimally greater than that of opposing force. So this is about the reversible process. And what is about the reversibility and irreversibility? The process which takes place in a single step. So driving force is large and finite is irreversible process, and the reversible process, the driving force is infinitesimally small, very small, so that opposing force and driving force हमेशा equilibrium में होता है. PV work is done across the pressure difference is very small dP का हिसाब से, small change in the pressure, and PV work across the pressure difference is delta P के हिसाब से जाना पड़ता है. And a reversible heat transfer carries place and the temperature difference dt. So differential amount you have to follow it. While you can see in the irreversible heat transfer takes delta t. So whenever the total magnitude change is irreversible, small infinitesimal change is called reversible. And you know, it takes infinite time for the completion of the process. It is a hypothetical, and maximum work is extracted from reversible process. While you can say you're going to take, it's a real process, it actually happens, and maximum work done is not extracted. Okay, this is about the irreversible process. I just want to say here it is what I can say about the reversibility of the process. A system in which the piston is here and it is released in n number of stages and it is coming back. So expansion and reinstating, and this is a diagrammatic expression that can show you the reversibility of this. And what is there? It is ideal gas. What is there? It is an ideal gas is present. Ideal gas expansion and compression. Okay. Any doubt? Hitesh and Yogita and also Chaitra Shri. Anuj Gope is there in the class now. Love from Madhya Pradesh. So there are so many students admiring our class and attending on the regular basis. Betu is there, Anuj Gope is there, and I'm waiting for them. Okay, and moving ahead about the irreversible process, you just say here ice is melting, and you can see air and stone is there. Okay, in this process nothing is changed, the state of the matter is changed in one step, that is called irreversible. You can't change in the reverse way unless you do some external work. It is called irreversible process. Fine. Show us some love, please. Like the session. Okay, moving ahead here, wonderful slide for you. Reversibility of the process. System is always thermodynamic equilibrium at every stage of the process, and this carried out infinitesimally slowly throughout the series of equilibrium states. So when the system is changing n number of steps, each step it is experiencing equilibrium. So that is a reversible process, and at any moment the direction of the process can be reversed, and by infinitesimal small change, and a system surroundings can be restored back to their original state. And also irreversibility of the process, it is a real process. All the naturally occurring processes are irreversible. Melting of ice at room temperature is actually a reversible process, and it takes a finite time में ये process करना चाहिए, and driving force is substantially greater than the opposing force. So dear children, we are giving a very good noteworthy points that can help you to proceed accordingly. Are you getting or not? Any doubt, bacho? And in the irreversible process, exactly, my dear students, those who are online, please like the session, please. And system may be in thermodynamic equilibrium. I don't say it should be exactly at thermodynamic equilibrium, and it states that some finite number of intermediate stages, and it is carried out in a definite number of steps, and the process it goes from initial state to the final state in a finite steps or a single step, kam se kam mein. And a reversal of the driving force does not restore the system and surrounding back to their original state. Once it is gone, it's gone. Fine. And it is very important, and maximum work done is extracted from reversible process but not from irreversible process, right beta? And also talking about internal energy, it's a super important point. So the term is self-explanatory, Baya, right? So every system having some quantity of matter is associated with a definite amount of energy is called internal energy. That energy is called maybe kinetic energy and potential energy, translational energy, vibrational energy, nuclear energy, rotational energy, and all kinds of energies. And it is a thermodynamic state function, and it is an extensive property. It is impossible to find absolute value of any state function, but you can measure the change in the state function. So absolute value of internal energy आप नहीं निकाल सकते, but delta U can be calculated. Delta U is equal to U2 minus U1, है कि ना? And also, so internal energy, total energy contained within the system. It could be translational energy, rotational energy, vibrational energy, electronic, nuclear, and all kinds of energies that scientists has discovered, and other kinds of energy that had to be discovered. So all kind can't be measured. You can't measure the absolute value of this internal energy. Okay. Now moving ahead, changes in the internal energy. Delta U is equal to final internal energy minus initial internal energy. It can be measured. Can be 0, it can be positive value, or it can be negative value also. I want to talk about the change. I am talking about the change in internal energy, but these values magnitude you have to check. And also बच्चों here general terminologies. So thermodynamics करने का वक्त में ये slide काफी important है बेटा. So every point that I am giving, so the properties which depend on path, okay, that is heat and work. Okay, W is equal to P delta V. If work is done on the system, W is going to be positive. Work is done by the system, W is going to be negative. और फिजिक्स में अपोजिट दिखता है, लेकिन नीट एग्जामिनेशन में आप एनसीईआरटी को बोलते रहते हैं ना, एंड यू हैव टू फॉलो दिस. NCERT follows IUPAC. So W is equal to positive. Okay, work done on the system. W is going to be negative. Work done by the system. Are you getting or not? Work done on the system, work done by the system. The sign conversions. Compression, work is done, so it is going to be positive. And expansion, work is done by the system, that is going to be negative. Okay, that's very important. You know, this is the system, work is done on the system is going to be positive. Okay, work is done by the system is going to be negative. And heat is given to the system, Q is going to be positive. Heat is coming out of the system, Q is going to be negative. Like this is the conversion hierarchy you need to maintain in order to be so strong in the thermodynamics. समझ में आ रहा है बेटा? बच्चों अगर कुछ डाउट है ना तो चार्ट बॉक्स आप इस्तेमाल करके बोलना है. And to have this kind of lecture from your senior faculty, you need to go to the coaching center, you need to use long time duration for travel and pay huge amount of money. But here YouTube में आप चिंता मत करना, it is absolutely free of cost. You can attend our class without any hassle free and take a pen and paper and write noteworthy points. And अगर कुछ doubt है ना तो chat box में कर सकता. You can attend the live classes. Please like this session and subscribe to this channel. So the अगले क्लास कब होगा, कैसा होगा, सब शेड्यूल आपको पता होना चाहिए. चाहे टेलीग्राम चैनल पे भी आप ज्वाइन कर सकते हो. एंड आज का जो क्लास है ना, ये क्लास के सारे ये नोट्स आपको पीडीएफ फॉर्म में आपको टेलीग्राम चैनल में मिलेगा, है ना बेटा. Everything you see here, the unit of work, atmosphere into liter atmosphere. In this liter atmosphere, 1 liter atmosphere is equal to 101.3 joules, and also 1 calorie is equal to 4.18 joules. Physics sir pata hai. And 1 joule is equal to 107 ergs, and 1 joule is equal to 0.24 calories, and you use this conversion table to do the best out of it. Okay, any doubts bachcho? I'm expecting you guys to ask any kind of doubts. Okay, so moving ahead. So here we have thermodynamics laws. First, which law you want me to start? So class कम से कम थोड़ा सा इंटरैक्टिव रहना चाहिए. So you have zeroth law, first law, second law, third law. And as far as chemistry is concerned, so more focus should be given first law. And let us talk about the zeroth law. So zeroth law is such an important and easy one. Let us hit it. So, zeroth law. Zeroth law says that if three systems are taken into the consideration, I will tell you. This is a system A, system B and system C. Let me explain this. If system A and B are in thermal equilibrium separately, and if the system A and C are also in thermal equilibrium, then you can say that system B and C are also in thermal equilibrium. That is what is called as a zeroth law. If two bodies A and B are in thermal equilibrium with another body C separately, then A and B are also in thermal equilibrium in each other. It is a phenomenal. That's what it is said that if A and C, A is in thermal equilibrium with C, and also C is in thermal equilibrium with B, then you can also say A and B are also in thermal equilibrium, that he wanted to say. So, it is what is called zeroth law of thermodynamics. You can say temperature of A is equal to temperature of B. In the other case, if temperature B is equal to temperature C, then we can say temperature A is equal to temperature C, and this is the diagrammatic illustration can help you out of this. In the NEET examination, yes, never leave any single concept. You have to study and rise it to get 4 marks directly from thermodynamics. And moving ahead here, zeroth law का थोड़ा सा definition भी काफी important है बच्चों. And you can say, I love this first law. What first law says? First law का जो definition है ना, 20 different types of definitions are there. Energy can neither be created nor be destroyed, but can be converted from one form to another. Array, weird conversion jokes are also there. Being a teacher, I don't want to say this. Okay. So, the total energy of an isolated system is always conserved. Which of the following is true? Is a common question phrase comes in the NEET examination. Bacho here. If a certain quantity of energy is disappeared, equal quantity of work should be appeared. That is also said to be first law of thermodynamics. If certain quantity of certain energy is disappeared, same quantity of energy of another form has to be appeared. Arey beta, it is impossible to construct a continuously moving machine which can work without continuous supply of energy. That is also first law of thermodynamics. So, the system can exchange energy with its surrounding by heat or by work. Right, beta? Hitesh and Yogita and you see Chaitra Shri. So, follow here what we can do here. Now, so the heat, I want to talk about the heat. Whenever I say heat, it is nothing but your thermodynamics energy. The heat is energy transferred across the boundary as a result of temperature difference between the system and surrounding. So, I want to say this is the hotter body and this is the colder body. When they are physically in contact to each other, the heat is going to be transferred from hotter body to colder body irreversibly and spontaneously. So, heat flow from energy from high temperature to low temperature. And I want to say ताकि ये work क्या होगा? So, work is the motion against opposite force. So, I hate physics, but I am forced to use physics. dW is equal to F of dx and force and the displacement of the vector quantities. And F is equal to force, dx is the displacement change. And you can see, and heat and work both made of mode of transfer of energy. Heat can be converted into work, work can be converted into heat. And it is a path function beta, and SI units is going to be joules. And also, And you see, the first law of thermodynamics is a beautiful picture that can talk. So it is first law of thermodynamics talks about internal energy change. And first, what is the condition? Heat passes into or out of a system, then internal energy can change takes place, and work is done on the system or by the system, then internal energy change can take place, and matter enters into the system on the leaves of the system, open system, so internal energy of the system can change. And these are the three conditions. Which of the following can bring you internal energy change? MCQ NEET examination में आपको फंस जाएगा. You guys, what you do, you study thermodynamics. फॉर्मूलास रेटा मारना, न्यूमेरिकल्स करना है, ये कोचिंग सेंटर मटेरियल करना, टीचर का नोट्स करना, MTG करना, वो अरिहंत करना. All materials are done. I ask you a simple question, a theoretical question. Which of the following can cause internal energy change? A, B, C, D, and D is all the above. So, explain the condition 3. Matter enters and leaves of the system. Okay. And internal energy is an extensive property beta. अगर mass बढ़ जाता तो internal energy बढ़ जाता. Understand? Clear? Simple. That's a simple logic. Are you getting or not? And moving ahead, the mathematical expression for the first law of thermodynamics. अरे बेटा ये क्या? मेरे को जब numbers दिखते हैं ना, equation दिखते हैं ना, डर लगता. Don't worry, मैं हूं ना. And you see, this is a system बेटा. This is a system. ये जो system है, and you can see this is a system. In this system, इसका इंटरनल एनर्जी U1 था. ठीक है बेटा, इसको थोड़ा सा हीट सप्लाई करना चाहता हूं ताकि साइमल्टेनियसली कुछ वर्क भी करना चाहता हूं, सो दैट सिस्टम का जो इंटरनल एनर्जी U2 तक बदल दिया. ठीक है बेटा. सो U2 क्या होगा? पहला जो इंटरनल एनर्जी U1 था, एंड इसका Q दिया एंड W भी किया. सो U2 minus U1 is equal to Q plus W. That is called delta U is equal to Q plus W. That is what is called the first law of thermodynamics. First law of thermodynamics. And you just understand how to use this first law of thermodynamics ना. नीट एग्जामिनेशन, चाहे आपको जो भी एग्जामिनेशन मान के चलो, आपका 4 मार्क्स आपका पॉकेट में है. डोंट लीव द मार्क्स ऑन द टेबल, गेट द मार्क्स इन योर पॉकेट. ओके योगिता, Chaitra Sri. So can we take a minute break? Can we take a minute break? So that it's a long session, so we can take a couple of minutes break. Yes. So get ready. We'll meet exactly after 7 minutes. Fine. Don't leave the session and stay with us, and we'll be doing and have a refreshment, and I'll come back. You do have refreshment. Okay, I'll have a hot water and I'll be back. ठीक है? Hello students, I am back here. So let's continue our discussion. So Nalia, you're not understanding. You just ask where you don't understand so that we can have a discussion here. Bacho. So this is all about the first law of thermodynamics here. Students, I am back here and let us start with the first law of thermodynamics here. When the system is at U1 internal energy, is given some heat Q and work is done on the system W. So that system changes its internal energy U2. So U2 is equal to U1 plus Q plus W, and U2 minus U1 is equal to Q plus W. U2 minus U1 is equal to delta U is equal to Q plus W. This is what you can say the first law of thermodynamics mathematical expression. So you tell me, I changed the mic, you can all hear me. You can all hear me. Yogita, Hitesh, Chaitrasri, any doubt? You please. Yes. Now moving ahead here, a system, it is at a state 1 and is changed to state 2. So it is doing some work and the heat transfer is going to be Q, and it is going to be delta U is equal to Q plus W is called as first law of thermodynamics here. And also moving ahead, sign conversion of heat and work. If the work is done on the system, W is going to be positive. If the work is done by the system, W is going to be negative. Okay, if the heat is given to the system, Q is going to be positive, and heat is coming out of the system, Q is going to be negative. So negative anything which decreases energy of the system, positive anything which increases energy of the system. That's a very important sign conversion. Heat released by the system, negative. Heat absorbed by the system, positive. Work done on the system, positive, and work done by the system is going to be negative. These are the sign conversions. Directly you can use it, bacho. And heat capacity. It is the amount of heat that is supplied to the system changes the system by 1 degree. That is what is called a heat capacity of a system. So a system changes, let us say 35 to 30 degree सेंटीग्रेड बढ़ने के लिए कितना एनर्जी इसको देना चाहिए, that is what is called a heat capacity. Water has high heat capacity, you know that, and lots of energy is needed to raise the temperature. And you see here the heat required to raise the temperature of a system by 1 degree under a given process, that is called Ct is equal to dq by dt. And majority of the question you can draw it from this particular heat capacities, bacho. And you can see here it is an extensive property and it is a path function. Hi Kastur, hello, please like the session. And it could be Ct is equal to dq by dt, and dq is equal to Ct del dt. And if you integrating from a system state 1 to state 2, integral dq is equal to integrating Ct dt, and Ct is independent on temperature, you are going to get q is equal to C delta T. And here heat supplied to change the temperature from T2 to T1, T2 is greater than T1. And I want to say here that heat capacity is of two types. One is a specific heat capacity, another one is a molar heat capacity. So let's talk about a molar heat capacity. The heat required to raise the temperature of 1 mole of the substance by 1 degree is equal to molar heat capacity. Okay, and it is going to be molar heat capacity. So that is going to be dq n delta T. Okay, and I want to say specific heat capacity is the heat required to raise the temperature of 1 gram of a substance, and we can measure all these things. Okay, and you can see here this specific heat molar heat capacity. So that is molar heat capacity is equal to dq by n dt, and n is the number of moles. And you can measure this molar heat capacity at constant volume. You can say it is going to be Cv, and you can measure the molar heat capacity at constant pressure, that you can say it is a Cp. And the relation between the Cp and the Cv is very important, much more in physics and less in chemistry, and you will be having a table based on that. You can just go ahead with that. I want to show you the relations between this Cp and Cv. And here specific heat capacity, the heat required to raise the temperature of 1 gram of a substance by 1 degree centigrade, that is S is equal to dq by n dt. M dt, m is the mass of the substance, and it is an intensive property and it is a path function. And on integrating S, you are going to get independent of temperature. Both molar heat capacity and specific heat capacity are independent on temperature. And moving ahead, molar heat capacities you can have for different processes, and directly these formulas can help you. For isothermal process, Cm can be minus infinity to plus infinity. For isobaric process, Cm is equal to Cp m, and isochoric process, Cm molar heat capacity is equal to Cv m, and adiabatic process, Cm is equal to 0. And these are the limits you need to know about the molar heat capacity. And also you just see the expression for the PV work when the cylinder, a ideal gas, is enclosed in a freely movable piston, and it is going to be expanded from the volume V1 to V2, and in a single step you can say work done is equal to minus P external pressure V2 minus V1. Okay, or otherwise work done is equal to minus P external and delta V, and this can answer a number of questions in the NCERT textbook as well as NEET examination. Very, very important. If the external pressure is 0, you need not have to derive it. So it all depends upon the constant external pressure. And it is an irreversible process. Expression for PV work done, finally got this. And if it is, okay, remember P into V is equal to liter dot atmosphere unit of energy. 1 liter atmosphere is equal to 101.3 joules. That's very important. This conversion is important. 1 liter atmosphere, because you are going to do all the heat work in liter atmospheres. And you know, essential mathematical expressions for the first law. Okay, du is equal to dq plus dw, and at constant volume isochoric process, dw is equal to 0 and du is equal to dqv. So du is equal to ncv delta t. So you can use this formula for isochoric process. So at constant volume isochoric process में ये formula आप इस्तेमाल कर सकता हूँ. Are you getting or not? Kastur, Nalia, and Yogita, Chaitrashri, all students who are there, you can just watch this. And also for a work calculation in a reversible isothermal process. So what is the making a difference between a reversible process and irreversible process? Reversible process, multiple steps, and irreversible process, single step. So you can just use irreversible process. So W is equal to minus P delta V. And reversible process, you can use integrated expression 2.2303 wala hai na, yaad hai? I'm going to show you this. When a system changes in one step, to another step, there is a change in the volume. There is a change in the volume. You can see there is a change in the volume, right? And this is the change in the volume. For this change in the volume, you are going to see change in the work also. So you have to take this change in the work and integrating, you are going to see work in the reversible process. You are going to integrate from initial state to the final state of P external, right? So as dP and dV is very small, you can ignore it mathematically. So on doing so, work done in the reversible process is equal to minus nRT integral V1 to V2 and dV by V. Okay, as pressure of the external gas is equal to nRT by V, PV is equal to nRT, है कि ना? So the pressure इसमें डाल दीजिए and you are going to get the finally Ni minus nRT V1 to V2 dV by V. On doing so, you are going to get nRT ln V2 by V1. Kasturi, and since you know this ln x is equal to 2.303 to the base 10 log to the base 10 of x. So finally you are going to get work done reversible is going to be 2.303 nRT log V2 minus V1. And according to V is directly proportional to T, V by T is constant, okay, V1 by V2 is equal to T2 by T1, and you are going to see, and W reversible process, you are going to see minus 2.303 nRT log P1 by P2. So pressure and volume are inversely related Boyle's law का हिसाब से. So V2 upon V1, P1 upon P2. Okay. This is isothermal process. जब तक temperature constant है, you can use Boyle's law. Understand? Moving ahead, isothermal reversible compression. If the gas is expanded, work done by the system. If you compress it, P external changes such that it is always infinitesimal higher than P gas. Suppose we keep a sand on it and we are just particles slowly on the movable piston. So each step one particles falling on a piston compresses infinitesimally small volume. And ये जो पूरा जो derivation है ना, it is going to be a reversible process, is going to be ये rectangular hyperbola का जैसा होता है, and it is going to be expansion, W is going to be negative, compression W is going to be positive. And you can see work calculation for irreversible isothermal process. Irreversible में क्या होगा? Irreversible में होता है आपका single shot, finite number of steps, and you are going to be P external is equal to P ATM जब तक ये compression और expansion चलते रहते हैं. And removing a brick, expansion of the gas takes place in the constant external pressure, so that you can directly take, so work done is equal to minus P external delta V. Whenever irreversible comes, now this is only the way. And two step expansion, one step expansion कुछ नहीं होगा, इतना लंबा नहीं चाहिए. And I want to show you important thing here. Yes, I will show you. So work done compression graphs are very important. These graphs are very important. Work done comparison for isothermal process, reversible expansion, irreversible expansion. Irreversible में एक ही step, initially यहाँ से यहाँ तक expand कर रहे हैं, only a step, one step, and ताकि इसका pressure भी ज़्यादा चाहिए. Now it is a reversible, it is moving from this state to this state n number of steps. So you are going to get a rectangular hyperbola. So by looking at this graph, we can say whether it is a reversible process or irreversible process. You know, always magnitude of the reversible process is always greater than magnitude of the irreversible process. Okay, beta? Kasturi, if you have any doubts, please let me know. Right. Now, in this reversible compression, the process is going to be reverse. That is called compression. This is what is called compression. The graph is going in this way. This is what is called compression. Are you getting or not? Volume is increased, expansion, volume is decreased. It is called compression. And you see here, and conclusion, ये story का moral क्या होगा बेटा? So output, work done by the system. I mean to say piston moving out, piston moves out. Okay, and input, piston is going down, compression, work done on the system, right? And work done on the gas, minimum in reversible process and maximum in the reversible process. Minimum in work done on the gas, minimum in the reversible process, and work done by the gas, maximum in the reversible process. Okay, so these are the terminologies you need to be acquainted, and you try to give the questions in 2026 NEET में ऐसे questions NEET examination को MCQ के आने का संभावना है, न्यूमेरिकल्स कम आ सकता है. What NEET is going to test you, how extent you are able to understand the concept, right? And moving ahead, so remember always process is reversible when expansion, compression again is a constant external pressure, and change is sudden, then it is going to be reversible, right? And also you can say isochoric process and isobaric process. Isochoric process is the process, the change in volume is 0, dV is equal to 0. ताकि W is going to be 0. Simply apply delta U is equal to Q plus W, and W is equal to minus P external delta V. Isochoric process, dV is equal to 0, W is equal to 0. So W is equal to 0, delta U is equal to delta Q. Understand? You can apply that isobaric process, dP is equal to 0, when dP is equal to 0, and here pressure is constant, work minus P external, change in the volume for a reversible process. And for both reversible and irreversible process, work done is going to be 0. And also adiabatic process, Q is equal to 0. Heat exchange is 0. And heat can neither enter nor leave the system. From the first law of thermodynamics, Q is equal to 0 ताकि W is equal to delta Q. I mean to say work done by the system or on the system. Work done on the system can increase the internal energy. Work done by the system can decrease the internal energy. So that is what is called adiabatic process. So adiabatic process, you have a formulas, you can calculate that. And adiabatic expression, work done is negative, work done, negative work done, negative internal energy, T decreases. See how this composition is given, my dear children. And work done by the system at the expense of internal energy, so that cooling occurs. Air condition ये principle से जाते हैं. Any doubt बच्चों? अगर कुछ doubt है ना तो जल्दी पूछना. Now moving ahead, if W is positive, internal energy is going to be positive. So T increases. So work done on the system which increases the internal energy. Internal energy increases and temperature increases. Garam hona chahiye, heating effect. You know, energy is directly proportional to temperature and internal energy is directly proportional to temperature, right? Now moving ahead, adiabatic process, no heat exchange between the system and the surroundings. So that we can say, so NCV dt is equal to minus P external dV, and these formulas you can say, you can use this as, since Cp, that is molar heat capacity at constant pressure, minus Cv is equal to R. Cp minus Cv is equal to R. R is a gas constant. And Cp upon Cv minus 1 is equal to R by Cv. So from there, minus 1 is equal to R by Cv, and Cv is equal to R by 1, R by gamma minus 1. This is gamma beta, this is gamma. And gamma is equal to Cp by Cv. This is called as a Poisson ratio. And this Poisson ratio, this ratio can tell the behavior of the gas and the nature of the gas. It is all depends upon the monoatomic gas, diatomic gas, polyatomic gas, like that. Okay, you can say for a reversible, I will show you that. Okay, yes. And finally, you can see here Cv is equal to ln T2 minus T1 is equal to minus R ln V2 upon V1. अरे इतना सारे डिटेल्ड वर्जन ऑफ डेरिवेशन हमको चाहिए, केमिस्ट्री में बिल्कुल नहीं चाहिए. And reversible adiabatic process depends on initial temperature, final temperature and initial volume and final volume का ये कंडीशंस का फॉर्मूला का हिसाब से कुछ भी ना कुछ ग्राफ का बारे में क्वेश्चंस आने का संभावना है, फॉर्मूला के बारे में आने संभावना है, एंड न्यूमेरिकल ऐसे नहीं होगा. And you can see here, I will show you direct formula, yes, yeah, already given this. So Tv to the power gamma minus 1 is equal to constant. This is the condition for adiabatic process. And P1 V1 power gamma is equal to P2 V2 power gamma. क्योंकि PV to the power gamma is equal to constant. So PV to the power gamma is a constant valid only for reversible adiabatic process. This is a very, very important. Which of the following is true? Gone. You prepare your NEET examination, whatever the competitive examination, in such a way that you do big numericals, but theoretical questions, validity क्या है? PV to the power gamma is equal to constant. It is, everybody knows it is valid. किस कंडीशन में? रिवर्सिबल एडियाबैटिक प्रोसेस में. सिमिलरली यूजिंग आइडियल गैस इक्वेशन वी कैन हैव रिलेशन विथ P as well as T here. Okay, now for monoatomic gas Cp Cv ratios and degree of freedom, इतना काफी, इतना चीज नहीं चाहिए, degree of freedom kind of things in the chemistry which we don't need it. And Cp Cv ratios are important for chemistry. So for monoatomic, Cv is equal to 3 by 2 R and Cp is equal to 5 by 2 R. For diatomic, 5 by 2 R and 7 by 2 R for Cp. And Cp minus Cv is equal to R. I will tell you R value chemistry करने के लिए आपका to calorie Kelvin inverse mole inverse इस्तेमाल करो बेटा. So if you do so, you are going to calculate Cv value so easily. If required, you can convert into joules later. So multiply with 2 is simple, na? Why don't you use the smartest way? You like it? Those who are online, please like this session and share with your friends. Subscribe to Infinity Learn NEET YouTube channel so that we can have an excellent discussion about the various things, and we'll go into the entropies then. And work done in reversible adiabatic process, W is equal to, this is very important. This is very important. You memorize this formula. Okay. W is equal to P2 V2 to the power gamma V2 power 1 minus gamma minus P1 V1 to the power gamma and V1 1 minus gamma upon gamma minus 1. This is done from PV to the power gamma is equal to 0. So use this formula only. काम चलेगा. योगिता, Chaitrasri and Nalya and Kasturi. Follow this and moving ahead here for an ideal gas. मान के चलो, it's very important. For an ideal gas, total work done in a reversible adiabatic process, W is equal to P2 V2 minus P1 V1 upon gamma minus 1. What is gamma? Cp upon Cv. Poisson ratio, no? And you know, बच्चों for irreversible वाला क्या सेम है, W is equal to minus P external delta V से आप derive कर सकते हैं, and you are going to get for an ideal gas W is equal to P2 V2 minus P1 V1 upon gamma minus 1. Okay, so W is equal to N or of T2 minus T1 upon gamma minus 1. From that's good beta. And if a state A इसका condition में P1 V1 T1 or the conditions, in the reversible process state 2 बन गया P2 V2 T2 state का, and it is going to be a reversible process in a single step and irreversible process in a multi-step. And for adiabatic process, I want to say if two states are linked by an adiabatic reversible and irreversible path, then it is logically not possible. It is logically not possible. W irreversible is equal to delta U irreversible. W reversible is equal to delta U reversible. It is logically not possible. मैं क्या बोलना चाहता हूँ? And W internal energy reversible is equal to internal energy irreversible. It is a contradiction as W is a path function. This cannot be. If we assume W reversible is not equal to W irreversible, see the logic in the thermodynamics. It implies that delta U reversible is not equal to delta U reversible, and which is again is a contradiction as delta U is a state function. So it is delta W is a path function and delta U is a state function. It is actually not supporting either sides. It's contradicting to each other. बच्चों मैं क्या बोलना चाहता हूं? This is the conclusion. If two states A and B can never lie both in reversible as well as a irreversible adiabatic path. यकीन नहीं होगा तो देखो. Any doubt बच्चों? Now, graphical comparison of different type of thermodynamic process. For reversible isothermal process, we are going to see various graphs. We already seen these graphs just for rolling out this. And isothermal curve and adiabatic curve is coming. So, P adiabatic is less than P isothermal. Okay, and you can see here isothermal V adiabatic is less than V isothermal. So these are the conditions you need to learn, dear children. And also, most chemical reactions are carried out in constant atmospheric pressure, not at constant volume. So we need another thermodynamic property that is called enthalpy. Need to define another state function that we are going into the expression, that is enthalpy. So what is enthalpy? Internal energy is the heat at constant volume, and enthalpy is the heat at constant pressure. So that makes the difference between the enthalpy and entropy. And this enthalpy, sum of the internal energy plus PV work of a system under a given set of conditions. So I mean to say delta H is equal to delta U plus delta nRT. So this can give you a super impact on the NEET examination. What is delta N? Delta N, कौन बोल सकते हैं? Those who are online, please tell me what is delta N. So delta N is equal to sum of the number of moles of the gaseous products minus sum of the number of gaseous reactants. So this is about the enthalpy. Are you getting or not? Are you getting or not? Clear? Now this is the enthalpy and it is a state function and it is an extensive property. It is impossible to measure the absolute value of enthalpy, but you can measure the absolute change in the enthalpies. So in a chemical reaction, reactant gives rise the product, and delta H is equal to sum of the enthalpies of the products minus sum of the enthalpies of the reactant. Okay, so you can measure from it. So delta H is equal to U plus PV work done. PV is equal to the nRT. Delta H is equal to delta U plus delta nRT. So measure of heat change evolved or absorbed taking place during a process at constant pressure, that is nothing but your enthalpy. You see, for endothermic process, heat is going into the system, so that is going to be delta H is going to be positive, and heat is getting out of the system, that is going to be exothermic process, heat is going to be, so that is enthalpy is going to be negative. So before thermodynamics, my dear students, if students are asking about what is enthalpy, when I am talking about ionization enthalpy in the periodic table, so students worried about what is enthalpy, sir, ionization enthalpy, enthalpy hota hai kyun? Are enthalpy is a fancy word for energy, bas. Thermodynamically, it is the heat of a system at constant pressure. इंटरनल एनर्जी एंड एंथैल्पी दोनों लगभग आसपास में होता है. So internal energy is heat of a system at constant volume. Enthalpy is a heat of a system at constant pressure. And दोनों का अंतर क्या होगा? Enthalpy is equal to internal energy plus little PV work done. है ना बेटा? So that is the way you need to understand thermodynamics बेटा. अगर कुछ डाउट है ना तो पूछना जल्दी फटाफट. So moving ahead, we had this discussion, okay, and for gases, for solids and liquids, change in the volume is 0 at constant pressure. P delta V is insignificant, ताकि इसका delta H is equal to delta U. Yes, and for a gas is V is significant. Change in the volume during the process is going to be significant. So the delta H is not equal to delta U. So that is signified based on this. Delta H is equal to delta U plus P delta V. For ideal gas, P delta V is equal to delta nRT. So at constant temperature, or is a gas constant, T is a constant temperature, I can say delta. So delta H is equal to delta U plus delta nRT. You can see delta N is equal to sum of the number of gaseous products minus sum of the number of gaseous reactants. Now I want to say here delta H is equal to delta U plus delta nRT. Na? Now you see, if delta N is equal to 0, then delta H is equal to delta U. If delta N is greater than 0, then delta H is greater than delta U. And if delta N is less than 0, then delta H is less than delta U. So like that, various combinations are there. Which of the following can have these relations? And NEET examination में इसका अंतर है, तो मल्टीपल चॉइस क्वेश्चन आ सकता. आपको डेल्टा U दिया जाएगा, डेल्टा H निकालना है बेटा. डेल्टा H दिया जाएगा, डेल्टा U निकालना है. डेल्टा N इज द की पॉइंट. कौन सा R वैल्यू इस्तेमाल करना? Given values can decide. First you see the options, you can use the R value. If it is given the calories, you can use R value is going to be 2 calories, Kelvin inverse and mole inverse. and R value can be 8.314 joule, Kelvin inverse and mole inverse. And these conversions are very, very important beta. Hi Kasturi, if you have any doubts, please let me know. And moving ahead, for an ideal gas, these are all the things is given. Ready to do some numericals? If you say yes, I will start. Now, moral of the story, relation between delta H and Cp and M, and you can directly get it. Delta H is equal to NCV plus RT T2 minus T1. Delta is equal to NCP delta T. This is important. This is delta T. Delta H is equal to NCP delta T. Delta T is equal to T2 minus T1. Okay. And delta U and delta H can be related here, and from it is written from the Poisson ratio and degree of freedom. Actually ये physics में काम चलता है, chemistry में इतना काफी नहीं चाहिए. And also it is very important, melting of ice or freezing of water. I want to say here, during the process the temperature doesn't change, but internal energy does change. Can you believe this? Melting of ice and freezing of water at equilibrium. So kinetic energy of the molecule remains the same as long as temperature is same. Potential energy of the molecules remains the same. I mean to say, so kinetic energy changes, but kinetic energy remains the same, and the potential energy changes because state is changed. And I want to say here, melting of ice, a potential energy change because of the interparticle interactions here. System is that as long as temperature is changed, internal energy is changed. Surrounding is 25 and inside is 0. So whenever temperature gradient is there, there will be a thermodynamic operation, so that heat is going to enter hotter body to colder body. Hotter body to colder body. Are you getting or not? Clear? Fine. And you can see the limitation of first law. The limitation of first law. So the first law has given no information about extent of the reaction under given conditions, and it has unable to predict the direction of the spontaneous process. And these are the limitations as far as the first law is concerned. And somehow I found it is impossible. Sometimes people are trying, but you are not able to get 100% efficient engine, which is not actually done. And for that we need to talk about entropy and the spontaneity and Gibbs free energy. That gives a lot of impact. When you study the thermodynamics, there are four major areas you are going to get a question. First law of thermodynamics, and delta H is equal to delta U plus delta nRT, and entropy. Second law of thermodynamics means entropy, and Gibbs free energy. So these are the four areas where you will see the question, right? Definitely there you can see a spontaneous process. The process which has a natural urge tendency to proceed by itself is called a spontaneous process. When you see melting of ice, okay, melting of ice at room temperature, okay, it is a spontaneous process. No need to do any work. ये खुद ही जाना पड़ता बेटा. And a non-spontaneous process, a process which proceed, okay, which do not have a tendency to proceed. You want to say the reverse. Water is converted to ice at 25 degrees centigrade. It is not it never takes place. It is a non-spontaneous process. So that is what is the driving force for this spontaneous process, and what is the condition for the spontaneous. So let's see here. So can we identify spontaneity using delta H? So what is the driving force? A system has a tendency to have lowest energy state. Lowest energy state. Energy is, stability is inversely proportional to energy. So that system always has a tendency to have a lowest possible energy, so that it has to lose its energy. So when it loses energy, all exothermic processes are spontaneous. Sometimes it may not be. So delta H is negative, energy decreases. It could be a condition or a criteria for the spontaneous. Condition for the spontaneous. समझ में रहे क्या बेटा? And also you can see before the partition is removed, pick a gas molecule from the left container, the molecule will be of a gas A. Pick a gas molecule from the right side container, molecule will be gas B. So in a container, okay, they are partitioned. And I want to say here, in this way, system has become less predictable, more disordered way. System always has very happy when it is disorganized, like you and like me. Okay, so system has a tendency to get disordered. That is what is called as a second law of thermodynamics. Here you can see here observations I want to say. Melting of an ice, so delta H is positive, it is spontaneous. Endothermic spontaneous चलता रहता है बेटा. And also evaporation, delta H is again positive, this process is also spontaneous. So मैं क्या बोलना चाहता हूँ, delta H enthalpy itself cannot decide the process of spontaneity. We need some other parameter. We need some other parameter. What is that parameter? We'll see here. So melting solid to liquid, it is a disorderliness increased. And evaporation, liquid to gas, disorderliness again increased. So मैं क्या बोलना चाहता हूँ, in an isolated system there is always a tendency to become more disordered way. So that is one of the criteria for the spontaneity. I say one of the criteria, but not everything. Okay, so here मैं क्या बोलना चाहता हूँ, enthalpy plays a good role, and disorderness plays a good role, and temperature also plays a good role. Melting of ice, it is spontaneous when it is at 0 degrees centigrade, minus 10 degrees centigrade, and plus 10 degrees centigrade. So it is going to be spontaneous, it is not spontaneous. Melting of ice will not take place at minus 10 degrees centigrade. Hey, kina? So temperature is also very good role here. Driving force, there are two driving forces. Tendency of a system to acquire minimum energy, system हमेशा इसका कम से कम energy रखने का कोशिश करता, and the tendency of a system to acquire maximum randomness. So system का randomness भी बढ़ने का कोशिश करता, and these two are going to be taken into the consideration to form the criteria of spontaneity. So properties of entropy. Entropy is given by a letter S. It measures the degree of randomness or disorderliness of a system, and also it's a state function. S is an extensive property जैसे enthalpy का जैसे, and for a chemical reaction, delta S is equal to sum of the entropies of the products minus sum of the entropies of the reactants. So it's a thermodynamic state function. Absolute value of this entropy cannot be determined, rather its change in the entropy can be determined. Okay, that's very important. If you have any doubts, please let me know. Moving ahead here, entropy change. Regularly in structure, if the structure has a regular structure or a crystalline structure, in the molecular and crystal structures, entropy decreases. For a given substance, lowest entropy crystalline solid will have, and a gaseous state will have highest entropy. So entropy of this solid is less than entropy of the liquid and is going to be entropy of the gas. You know, as temperature increases, entropy increases. That's very important. But I have a couple of questions. If you are happy, I'm going to ask you. And you know, in entropy, in a physical or a chemical process, as a system moves from the less random state to the more random state, entropy always increases. And also, you see boiling of an egg. You say egg is liquid in state. When you boil it, it will become solidified. You say entropy decreased. But the raw egg, the well organized, defined structure of protein is denatured, and the entropy of this protein is changed. So on boiling of an egg, denaturation of protein happens, so entropy increases. That's increases. So that for boiling of raw egg, entropy is going to be positive. Entropy is going to be positive. That's very, very, very important. So this is given in the NCERT NEET examination. May I say questions are there? Which of the following process there will be delta S is positive or entropy is increased? You can use this. Yes, of course. Assertion reasoning type NEET examination, this kind of questions are important. Yes, denaturation of protein. You know, biology students, you know the primary structure of protein, secondary structure of protein, and tertiary structure of protein. Right? Now, heat is added to the system, molecular motions increases, randomness increases, and entropy of the system and entropy, heat is changes. So entropy increases, temperature increases, randomness increases. But delta S of the system is inversely proportional to temperature for the same Q and the system. It is confused. You know, it is going to be S is equal to dq reversible by T. Okay, you can say this is S is equal to Q by T. So what is this? Again, as temperature increases, randomness increases. I want to confuse from this formula. Yes, that is so confused. How many of you have the same confusion? So change in the increase for the lowest temperature is going to be highest. I mean to say, here you can say, looking at this is going to give you a bad impression. I want to say system A, internal entropy is S1. If you give 5 joules of energy, it is going to be S2. This is at 0 degree centigrade में operation किया. And this is a system B at 25 degree centigrade. इसका S1 होगा, S2 बदल दे, इसको भी 5 joules energy देने के बाद. And you see the difference in the energy. The difference in the energy is delta SA, and it is going to be delta SB. Okay. So I want to say delta SA is greater than delta SB because it is taking place from the lowest part. At higher temperature, entropy is already high. Heat addition will not change the entropy much. Understand? That is very important, beta. Very, very, very important. Understanding thermodynamics is this. Not doing 100 numericals. You talk about your friends. Like, yeah, अरे कितना questions किया thermodynamics से आज? He said 100 questions. अरे you feel very bad that you did only 10 questions, no? So that is not, that is what you are creating and build upping a peer pressure. Peer pressure ज़्यादा destruction देता है. So you do 2000 questions also in thermodynamics, but you have to understand this. Okay, and I want to say, if the state A is changed to state B, it could be a reversible process or irreversible process in a different way. Since you say, since S is a state function, it is not dependent on delta S is reversible is equal to delta S is irreversible. Delta S is reversible is equal to integrating from the state A to B, Q reversible by temperature. Okay, and from doing so, various formulas will come. I have only one formula, delta S is equal to Q reversible by temperature change. Okay बेटा, अगर कुछ डाउट है ना तो जल्दी पूछना. And you can also say, yes, for entropy change of an ideal gas, okay, you're going to finally, where is that formula? Next slide में आपको दिखा देना चाहता हूँ. Yes, you use this direct formula. Okay, delta S of the system is equal to NCV ln T2 upon T1 plus N or ln V2 upon V1. एक ही formula. It is derived for reversible process but is also valid for irreversible process as S is a state function. S is a state function. Super important formula. इससे डेप्थ में कुछ क्वेश्चंस आने का संभावना भी नहीं है केमिस्ट्री में. यस डेफिनेटली ये फॉर्मूला आप सीधा इस्तेमाल करना हो. ये रिवर्सिबल चाहिए, रिवर्सिबल हो सकता है, ये रिवर्सिबल भी हो सकता है. ये दोनों प्रोसेस में एंट्रोपी कैलकुलेट करने के लिए आप इस्तेमाल कर सकते हैं बच्चों. Okay, students, can we take a couple of minutes break for now? Can we take a couple of minutes break? If you are okay, I will give it, and we can extend this entropy to second law and third law भी आना चाहिए. So थोड़ा time लगेगा. ये 3 घंटे का सेशन है ना, थोड़ा सा टी ब्रेक. Okay, just 5 minutes. ठीक है बेटा, fine. So 217 slides are there, 150 slide पर रुका हुआ. Okay, start. We'll be back. Stay tuned. Pari, hi. Yeah. So can you just see is my video is clear and screen is clear, right? Right. Now moving ahead here, entropy change for an ideal gas. So for an ideal gas, P1 V1 by T1 is equal to P2 V2 by T2. Right. So V2 upon V1 is equal to P1 T2 upon P2 T1. So delta S of the system is equal to NCV ln T2 upon T1 plus NR ln P1 upon P2 plus NR ln T2 upon T1. So we want to take it as a common. So we are going to see delta S of the system is equal to NCP ln T2 upon T1 plus NR ln P1 upon P2. So these are the formulas can help you out of it. And I don't want to show you much more of this type of derivations. And this is what is called a second law of thermodynamics. So calculation of delta S surroundings. I want to say logically this is a system and this is a surroundings. So if entropy of the system is decreased here, entropy of the surroundings should be increased. So that is the logic, you can use it. Change in heat Q surroundings is equal to minus Q system. Delta S surroundings is equal to minus Q system by temperature. This is entropy formula. And from there, you can also say, integrating from here and there, I just directly want to give you the final formula. From here, solid and liquids are incompressible, so that delta V is going to be 0. Pari, so that delta S is equal to NCV ln T2 upon T1. So I want to say here, for solid system, a copper block kept in the open atmosphere. So copper, it is T1 and bar say T2 tha. If T1 is greater than T2, heat is going to be released out. So इसका entropy कम होना चाहिए, surroundings का entropy बढ़ना चाहिए, है ना? So I want to say here, so delta S is from integrating from T1 to T2 dq reversible upon temperature, and delta S is equal to integrating T1 T2 ms dt upon T is equal to ms ln T2 upon T1. So here S is indicating the specific heat of the copper metal. So all logics are being discussed here. Nothing is going out of it. You please follow these formulas. And also, you can also say for a solid system in for surroundings, delta S surroundings is equal to ms delta T by T2. Fine beta. Moving ahead, entropy के बारे में इतना झंझट नहीं है. So entropy change of the universe is equal to entropy change of the system plus entropy change in the surroundings. So now we are going to present you what is second law of thermodynamics. I wanted to say here, leave it. Yeah, I want to take this. Let me just give you very important things here. Yes. So calculation of delta S universe for an isothermal process, that can be directly given as NR ln V2 upon V1 minus NR ln V2 upon V1 should be equal to 0, system ka, surroundings ka. Second law takes entropy of the universe always increases. Mean to say entropy of the system plus entropy of the surrounding should be greater than 0. I want to say this is what is called, for an irreversible process, the system A is at P1, T1 and V1 conditions say, it is going to get system B tak and P2, V2 and T2 tak jana hai. So delta S system is equal to NR ln V2 upon V1 and surroundings में minus Q system दोनों बराबर करना पड़ता. And I want to say Q system is equal to work done by the system. For an isothermal process we know this, and the Q system is equal to P delta V, so that P V2 minus V1 होगा, and the Q surroundings is equal to minus P external V2 minus V1 upon temperature. And you know, and from this derivation part will come. I don't want to show you the derivation. Okay, this is a reversible process only. We will go into the second law of thermodynamics directly. Yes. Phase transformation, no need. So here coming to the second law of thermodynamics. So let us discuss about what is the first law of thermodynamics limitation. We have first law of thermodynamics. In that first law of thermodynamics, we said 100% efficient engine cannot be constructed. Why? Because second law explain you cannot construct 100% efficient engine. ये क्या चीज़ है? Cheating. So a system is processing. It has to use the given energy to do the work, to increase little bit of energy to this. So I wanted to say there should be always increase in entropy in order to perform this work. So work cannot be done without compensation. Work cannot be done without increase in entropy. This is what is called a second law of thermodynamics. Mathematically, entropy of the system and entropy of the surroundings should be always greater than 0. So entropy of the universe increases. This is what is called as second law of thermodynamics, Kelvin and Planck statement. It is impossible for a system to undergo cyclic process whose sole effects are the flow of heat into the system from the heat reservoir and perform an equivalent amount of work by the system on the surroundings. अरे क्या ये cheating है? I will tell you. This is your favorite Rolls-Royce car. है ना? How many of you like Rolls-Royce car? Yeah. Now, if you give 100 joules of energy, 100 joules of energy, you have to do 100 joules of work. So actually this is not actually possible. Practically what is happening now? That is happening only maybe 95 joules. 95 joules. So 5 joules कहा जा रहा है बेटा? Not useful work. That not use. This is used for work, non-useful work. Non-useful work, that is increase in entropy. Entropy बढ़ने के लिए कर रहा हूँ. This is what is called as second law of thermodynamics, and it is explained heat transfer, hotter body to colder body it is. Okay, it is there is a Q by T change in heat is seen. This is what is exactly thermodynamics second law. And I want to say source T2, an engine will get work and a sink T1. So it is explained on the basis of the sink and the physics and all. So we don't use this physics here. We use the usage of the work, that is I want to say useful work and not useful work. So this is the second law of thermodynamics. Whenever the spontaneous process takes place in the universe, the total entropy of the universe increases. What is this? Entropy of the system plus entropy of the surroundings should be greater than 0. It is mathematical form of the second law of thermodynamics. Okay, and here the system plus surrounding should be greater than 0. एंट्रोपी चेंज ऑफ द यूनिवर्स हमेशा बढ़ते जाते हैं. एनी डाउट बच्चों? एनी डाउट? Now, Anush, I was waiting for you. You came late. You came late. Reversible process, entropy of the universe is going to be 0. For irreversible process, it is going to be system is equal to reverse of the surroundings. So, entropy of the universe is going to be greater than 0 for irreversible process, right? And entropy change, the sum of internal energy and PV is the enthalpy of a system under given conditions at equilibrium. At equilibrium, delta S is equal to 0. And moving ahead, I want to show you Gibbs free energy change. So, Gibbs free energy change. So, it is the actual, yeah, array you came late talking about idli in the lunch time. I was taking your name for many times. So, your name is seen here as Anush Gope. Sometimes you come from the Sonali Gope and you are from Madhya Pradesh. I know that you are a very good student preparing for a good, right? Okay, now a system parameter to predict the spontaneity of a chemical reaction is the Gibbs free energy, is the essential and conditional parameter. Want to say Gibbs free energy, it is actually the actual amount of energy that is used for the work done. So, it is given a state function, it is kilojoule per mole or joule per mole, and for a spontaneous process delta S is greater than 0. So, delta S universe includes delta S surroundings and a system. To avoid calculation of surroundings and system, we take another systematic parameter, that is Gibbs free energy change is an extensive property. So, it is the actual useful work, decrease in whose value is actually work for, it is usually used for work. And we are going to see heat that is given useful work and non-useful for work. Okay, so heat is going to be delta H, useful work delta G plus non-useful work T delta S. Okay, so delta G is equal to delta H minus T delta S. Bas, this is what is called Gibbs-Helmholtz equation. The quantity of work which is actually used for doing the process is called as Gibbs free energy. So, this is called Gibbs-Helmholtz equation. This Gibbs-Helmholtz equation can give you insight about the ताकि process spontaneous होगा, non-spontaneous होगा. So, let's talk about this, and I already gone for a spontaneous process. Delta S universe is increased, okay, and delta H is negative, delta S is positive, delta G is going to be negative to say a process to be spontaneous. Okay, so delta G is equal to negative, then only the process is going to be spontaneous. If delta G is going to be positive, that is going to be non-spontaneous process. That is what At constant temperature, the change in Gibbs free energy between two states are given as delta G is equal to delta H minus T delta S. And if the process is a spontaneous, delta G is negative, non-spontaneous delta G is positive, and at equilibrium delta G is going to be 0. It is a universal equation that can be used for any physical and chemical process. There is no exception in that. And for a process taking place at constant temperature and pressure, hi Elisa, good evening or good afternoon, delta G is greater than 0, it is going to be a non-spontaneous, and delta G is going to be less than 0, it is going to be spontaneous. And if it is going to be 0, the system is said to be equilibrium. And you see the magnitude of this delta H and minus T delta S. Here there are three parameters. Delta H is a parameter, delta S is a parameter, temperature is a parameter, right? So melting of ice is spontaneous when the temperature is greater than 0 degrees centigrade. Melting of ice is non-spontaneous when the temperature is less than 0. So temperature is also a parameter, can help you to tell the criteria of spontaneity. Here the process is spontaneous or favorable or non-favorable. What is the meaning of a process, spontaneous process? The process which takes place by itself. Non-spontaneous process, the process which do not takes place by itself. Okay, beta. So this is what the various forms of the spontaneity, and I want to give you a simple table for that. So that simple table can help you to answer any kind of question in the any examination. Okay, Anush. Here you can see this is the one. Delta G is equal to delta H minus T delta S. Okay. If delta H is going to be positive at height and delta H is negative, delta S is a positive, delta G is going to be always negative. So such processes are going to be spontaneous at any temperature. If this delta H is positive, delta S is positive or negative. So in that case, you are going to see this process is going to be spontaneous at high temperature, and delta H is going to be negative. So it is non-spontaneous at high temperature, and vice versa. You just take this particular slide into this, and definitely based on this only you are going to get जो भी नीट हो सकता है, CBSE हो सकता है, क्वेश्चन आने का संभावना है. बच्चों, any doubt? Any doubt? Very good. And Anush, no discussions or what? It is already discussed, right? Gibbs free energy state. Yeah. Case 1, case 2, all cases we discussed in the table, right? Yeah. Physical interpretation of the delta G. Physical interpretation. So the magnitude of the negative value of delta G indicates maximum amount of non-PV work or useful work. जितना नेगेटिव वैल्यू बढ़ता है उतना काम आसानी करता है, and electrical work that can be obtained from the system. Okay, as delta G value magnitude increases and the work you are going to be extracted is going to be increases, that is the physical interpretation of delta G. Okay, so let us say A plus B gives rise to C. Delta G value is equal to minus 10 kilojoules. And X plus Y gives rise to Z. Delta G value is equal to minus 20 kilojoules. So, कौन सा process आसानी तरह से आना है? So, X plus Y gives rise to Z takes place more effectively as compared to this. And I want to say P plus Q gives rise to R. So, delta G value is equal to plus 10 kilojoules. Okay, एंड ऐसे प्रोसेस कभी नहीं आगे बढ़ता, राइट बेटा? लेट हो गया क्यों? And this is about Gibbs free energy, physical interpretation of delta G, magnitude of the positive value of delta G, minimum amount of work required to be done on the system to make the process to be spontaneous. And that is the physical interpretation of delta G beta. And talking about the third law of thermodynamics, we are coming to the end of the session, bacho. So, entropy of a perfect crystal of a pure element and compound is said to be 0 at 0 Kelvin. Entropy increases, temperature increases. As temperature कम होना कितना तक कम हो सकता है? 0 तक कम हो सकता है, ताकि एंट्रोपी कम हो सकते हैं, इसका भी 0 हो गया। जब टेम्परेचर 0 हो, केल्विन होगा, टेम्परेचर डिग्री सेंटीग्रेड में नहीं है, 0 केल्विन होगा, तभी इसका एंट्रोपी इज गोइंग टू बी 0, क्योंकि काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू एब्सोल्यूट टेम्परेचर। जब टेम्परेचर 0 होगा, काइनेटिक एनर्जी ऑफ द पार्टिकल्स इनसाइड द बॉडी इज गोइंग टू बी एब्सोल्यूटली 0 एंड इट इज गोइंग टू बी इमोबिलाइज्ड. It is practically very difficult to achieve it, and it is every matter is said to be a perfect crystal out of it. Okay, this is about the third law of thermodynamics beta. Yeah, it is absolute entropy of the pure substance, and absolute value of entropy, unlike the absolute value of enthalpy of any pure substance, can be calculated by given temperature, and that is given as delta S is equal to integral 0 Kelvin से T Kelvin तक NC delta T upon T. So, if the phase changes between 0 to T Kelvin, and entropy of phase change will also be added to that. So, simply saying 0 becomes 0, but it is mathematical interpretation of this third law of thermodynamics is given like this. Bacho, you can say, so A moles of A, B moles of B gives C moles of C, D moles of D. Standard entropy changes can be calculated as entropy change during the reaction is equal to sum of the entropies of the products minus sum of the entropies of the reactant. So, it is said to be standard molar entropies has to be taken into consideration. So, today we had a very good discussion about entropies, enthalpies, and various terminologies we are talking about. So, this is your image that can give you the third law of thermodynamics. So, increasing temperature increases randomness, decreasing temperature decreases randomness. Entropy of a pure crystalline substance is 0 at absolute 0 temperature beta, right? And information about entropy is given by the slot, while the calculation is done by CLOT. What is CLOT? Second law of thermodynamics, but calculated by using third law of thermodynamics, right? So, my dear students, in this session I just want to conclude like we had a very good discussion about thermodynamics heading, why thermodynamics, how thermodynamics, basic terminologies, and heat, work, and first law of thermodynamics, zeroth law of thermodynamics, second law of thermodynamics. Now we ended with third law of thermodynamics. Now you please check the description box in this telegram channel में सारे के सारा notes का PDF format में आपको देना है. And of course today I had a great swell of session, and I like that your session, and please like the session, share it with your friends, and subscribe to Infinity Learn NEET YouTube channel. Okay, we are done for now. Thank you very much. We'll meet with more in thermochemical calculations in the next session. Okay, thank you, and please join in the one shot series. Okay, thank you very much. Bye bye.